Well, in this video I'm going to show a signal generator synthesized from mini circuits, that is the model SSG-6001-RC from mini circuits, and I just got it. I arrived from USA. Didn't get any damage apparently. It's a modern device. It's still being sold and it's quite expensive. It's like $5,000 or $4,500, probably plus VAT. Probably is $5 or something more US dollars, and I got it quite cheap for parts and spare and parts. So I explain a little what I did before turning on. I connected via Ethernet, USB. Fortunately I had a cable, 12 volts. It doesn't have a good range of voltage. Is from 11.5 to 12.6, so it looks that need quite precise stuff. So I connected to a power supply that must to be grounded. I don't know if someone have one that is not grounded. What I did also, the USB, I connected to the computer, but I used isolator, autocoupler isolator or something like that. Doesn't make a ground loop with the battery of the laptop. And I have the spectrum analyzer, but because I don't know if it's working or not, I don't want to damage the spectrum analyzer that I just got. I bought this to pair with this because it's 1 to 6 gigahertz, 80 decibels in range to cancel out the power. Internal, it supports pulse set, internally and externally, internal clock and output. So it has some scratch in the paint, but so you have mode in, that is empty, refer in, refer out, trigger in, trigger out. I guess trigger is to make pulses to external device. And I have a GPS dial that I will test it and connect it to this. And probably I will synchronize with the spectrum analyzer. The spectrum analyzer is 6.5 gigahertz, so they match very good. It's a very good device for this spectrum analyzer, I think. I added adapter to SMA. I have nice cables, mini circuits with radial adapters to SMA, but this is very rigid, so for this test I need to put this somewhere. I don't know how to. So to protect the SDRs also, well, they have always DC blockers, but I added a DC blocker from mini circuits as well, and a very bad cable to a NARDA attenuator. NARDA step attenuator is 16 steps of 10, 60 dB of attenuation. It's very nice. From the 85, and it's like new, but it's the more precise one that I have. It has not insertion loss. It's so nice, and it's better than this one that is very nice as well, and it's better than this one, especially in insertion loss. So I put it in 60 to try to protect the things, because I don't know if it will work. If it works, will be like a small lottery, so you will see it in video, or I will cry. Okay, I won't be able to fix this, and I'm not rich, so I will lose some books. That it's alright. We're gonna try. So it's powered already. I'm going to switch on. Well, at least light up. I can listen. Fun. So it's working. The fun. Yeah, I can note. So it doesn't have any more buttons. It's by software. I have installed already the software. It's very easy. So, but I didn't anything else. So it's here. So you can run via USB Ethernet. So I'm not very good with Ethernet things, so I'm gonna put a USB. Oh, cannot maximize, very simple program. Main, sweep mode, hop mode, pulse mode, or pulse mode. I don't know, my English is very bad. Multi-gen. So you can choose here the frequency, the power output. Because I have the 60 attenuator, I'm going to put this 39, that is 90. Oh, sorry. Minus 30. And I said decibels. You can choose here the steps, if 10, 11, whatever, with this bar, I guess. I don't know. Generator model, SSG-6001-RC, serial number. Well, it's showing a serial number, I guess, that is being recognized. I don't know, int ref, I don't know what is this. Firmware, update firmware, so can be, it's still a modern actual device. So I seen in March, this version of the software is from March of 25, so it's quite nice. Calibration, I don't know what it is. I'm gonna click calibration. It's giving the numbers, so and it's, look, operating time since last calibration 36 hours, not even a week, I guess. Or so, oh, this is nice. So it's in calibration, and it's being read, at least the internals, because it's telling the hours. So this is quite nice. Give me hope that this work will be a lottery, especially have that, and this one is, will be nice have it. Please mind, I don't know. store, I don't know what store, if store the calibration in a file or go to the shop to buy something on mini circuits. I have no clue, so I remove that. Oh, and now I apply, and now is the time of the through. So I'm going to open the output, later go to the SDR, to the RX, that I have a software-based spectrum analyzer. I made a video, you can check it, and this is a spectrum analyzer with tracking generator, just like that one, but less quality, but can do the same, even 60, and it does 6 gigahertz like that one. So it's fantastic stuff. I calibrated the other day with that. You have the video, and so it's receiving here. So I open the app, the spectrum analyzer app. You see, I have a spectrum analyzer with tracking, super generator like that one, and no pulses that I know, but and generator here 6 gigahertz, and in harmonics up to 12. It's impressive. So I turn on the spectrum analyzer, and I'm going to put 1 gigahertz and span 50 is alright. Gain, I'm going to put 25. Okay. And we can see the noise floor. Average video filter average 5 is alright. So alright. So maybe I can fit this in the screen. No. No. Oh, there is more stuff here. Oh, you didn't see that? It's hidden. It's not very good software. So, please, that works. We're going to see RF on. I need to put 1 gigahertz here. 1 gigahertz. So we okay. RF on. It's not seeing anything because we have 60 dB, 90 dB. But I should. I think this doesn't work, this device. I think I should be seeing it already, the signal. One sec. Well, pues I had a cable disconnected. I thought that disconnected, but it wasn't tight. So no signal possible. So I don't know where I have here. And I'm gonna try with the finger. Okay, these cables are very bad and they get loose very easy if you don't use the tool that always should be used. So that was the problem. Did you see with the hand? So alright, so the through time, I click, something appeared there. Pick. This is good signal. I think it's working because I have the attenuator very in 60, so it's 90, 105. We'll see. My God, it's so hard. This one with this so small. Sorry. Yeah, it's working. It's working. I don't know why it's not working the peak. Gas. And 95, 105. Now. So it's working. 1000. It's not connected the clock. So my God, I don't know what I'm doing wrong. Oh no. I should take all. No. So what I'm going to do, I'm going to put -10. -10. And I'm going to remove the... Oh, it's nice, it's working. One sec. Oh, there. It was very hard. The attenuator, I don't know. It's very small, the wheel. So -10. -6. So -10, 0. -10. So I have there 6 decibels, so 25. I'm going to put 0 in gain. I don't know, because it's giving -25, but it is -10. I don't know what is going on. So it's alright, doesn't matter. I'm going to connect to the spectrum analyzer. So I'm going to stop. Well, I'm going to make a sweep. Oh, this is nice. It's working. It's a $5,000 generator. I won't tell you how much I paid, but far of that. I couldn't believe that this would work. Maybe it's not working, maybe it lacks power, maybe, for example, and it's not useful for them, and was quote maybe more than the device. I don't know. We will see. Power sweep, frequency sweep. From 1 here, step size 1 megahertz. I'm going to put 10 megahertz because power, no, minus 20, minus 10. I'm going to put a full span here. Full one. So yeah, it's sweeping. It's sweeping as you can see. Alright. So I'm going to stop this. I'm going to stop the app. I don't know how to use this, my god. Off. I don't know if I need to do anything else. RF off. Oh, I need to remove this first to can turn off. Alright, it's off. So I know that is working. So I put this to this one, to the HP. That is a DC blocker, noise suppressor. I don't know. If it's only a DC blocker and they say noise suppressor to sell more, or any DC block suppress the noise. I don't know, but doesn't matter. I'm going to put in manual 20 dB. And in the software I'm going to put 20 dB. And well, better I'm going to make a sweep. Is what is more cool, no? So this is the same settings than before. Power minus 20. Step size hertz. I don't know. Start a 9 kilohertz. So I'm going to put here frequency, start frequency 9. I don't know how to use this properly, so You can leave me in the comments. 9 kilohertz. Start 9 kilohertz. No? Nine kilohertz. It should be stop frequency 6 gigahertz. I don't know what's wrong. Stop frequency 6 gigahertz. Start frec 9 kilohertz. Why? 10 kilohertz. 1 meg. Hola, 1 meg. Hola, pues aquí, 1 meg 6 gigahertz. Step size 3 megahertz. The same than the spectrum analyzer resolution bandwidth. So run sweep. Just to be sure I don't mistake in anything, I'm going to my god, I need to remove this to turn on this and sweep mode. Run the sweep. I guess it's working now. Oh yes, it's working. So if I do a mass hole, trace mass hole. I cannot believe it's working. I don't know if it has some problem in power, as you say, it's falling, but I don't know the specs. I guess it's alright, I don't know. We will see now in the specs. Now we'll be cleaning. I wait a little bit until finished. So happy. Well, it finished to clean. So what I'm seeing is here in the beginning is spot on. The power is perfect. So we have 20 there in the attenuator, and 20 there and 20 here, minus 40. So we have here minus 40. So that is absolutely fine. But if I go to the end, I have between 45, 44 and a half, stuff like that. So that would be checking the datasheet. that will be -20. That would be out of spec because should have plus minus 125 plus or minus. So 1 decibel up, 1 decibel dot 25 up or down. So I'm thinking, because this cable is really bad, that maybe is not is not doing the job. So I should connect the other cable, the good one, to test. But it's really will be fine. Alright, I'm gonna do it. I come back. So I connected a good cable, mini circuits, to the HP. This filter cannot be because it's NARDA is very good in theory and it's 12 gigahertz. So I removed the attenuation. So I'm going to have 10 here, -10 attenuation, and I'm going to put here -10. -10. I'm going to go to sweep mode, and all is the same, but I have here the sweeping. This analyzer have the fast ADC, the fast sweep option. So it is 120 milliseconds. So I'm going to put that. Sweep size, power. I'm going to put 120. No, the half. 6. So they can overlap in some moment. I guess, I don't know. I'm learning, so I'm going to put here a clean trace, clear whole match, and I'm going to sweep. So it should be -20, and it's starting in -20. Marker started at -20, well, half decibel down. But now, look, it's very well synchronized from the beginning. It has trigger. This one has trigger output and trigger input, and this one also have trigger input and output. Maybe I can synchronize them. I asked in the group, and someone told that maybe I can, and maybe even I can make a buffer or something like that. I don't know what I mean with that. Well, maybe what happened, maybe they discarded this one because it looks that won't fit the power levels, won't fit the specification. If I understand well the specification, output power accuracy. No, that is not. That is the accuracy, no the. Wait. Minimum typical mass power plus 10. I don't know. I'm so new that maybe I don't know even how to read the specifications. I don't know where to find this. Do you see? Trigger input output. This plus 10 dB, I guess the clocking. This is very nice, this device. Look, it's working very nice. At half speed, as you can sweep in power as well. Can go up and down, or in frequency, or in pulses. It's really nice. Probably you can make a kind of radar that is. I want to make one. So I don't know if you can see, if you can understand you have there the model, if you can see the dataset of MIDI circuits, or you understand, maybe you can find if it's normal output power accuracy in levels from -10 to 10 in gigahertz. I think I'm right. It's out of spec. I don't know. Maybe someone can. In marker, if I go to the end, is 4 decibels down. I think the maximum should be 1.5, 1 decibel and 25, for what I understand. So it's good for me, maybe not for a lab, and because that they discarded this and I paid what I paid. But for me is still crazy nice. So, well, I hope that you found this cool. I did. See you. Thank you for watching.